Hi folks, today we're going to focus on operations with complex numbers, otherwise known as imaginary numbers. Now, this whole time we've been working with real numbers, but what about that scenario where you take the square root of a negative number? For so long you've been told there's nothing you can do with it. Well, now we're here to show you a way where there is something you can do with it. It's called an imaginary number. Now, right here we have the variable I. I is going to be set equal to the square root of -1. So that's why you rarely, if ever, see I used as a variable for anything else, because in algebra it actually means something. I does mean the square root of -1. So if we come to this first example, the square root of -16, you've been told in the past there's nothing you can do about that. Well, now we can. We can break this apart into the square root of -1 times the square root of 16. Now, the square root of -1 has a value. It's I. And then the square root of 16 is 4. So now, how this is typically written is 4i. And that is your answer. So here we have another example, the square root of -50. So first of all, we're just going to break out that square root of -1, I. Now we're going to break off that square root of 50, and that we can take apart a little bit further. There is a perfect square that comes out of that 50. So the square root of 50 we can break down into the 25 and 2. So this whole time we have been multiplying. So this square root of -1, or I, just follows down with it. So we have I times the square root of 25 times the square root of 2. Well, the square root of 25 we know is 5, so we have 5 times I times the square root of 2. And there it is broken down as much as you can make it. So here are a couple of examples of possible scenarios where you could see the square root of a negative. So if we're solving for x and we run into this scenario here where x squared is equal to -13, and we need to finish solving for x, we need to take the square root of both sides. So now, since we're solving for x, keep in mind, we are going to have plus or minus square root -13. Now, since we have the square root of negative, we need to do something about that. So anytime you see the square root of a negative, you have to automatically think I. So now x will equal plus or minus I square root 13. And that's as far as we can go with that. Square root 13 does not have a perfect square that comes out of it since it's prime. Now we come over to this other example. Again, we need to get x alone. So we start out by subtracting 11 from both sides. So we'll have 2x squared equals -48. We still need to work on getting x alone, so we can divide both sides by 2, so x squared would equal -24. Now we can square root. So square rooting both sides to finish getting x alone, so we have x equals plus or minus square root -24. And again, we have that square root of negative, so we must automatically think I. So plus or minus I root 24. And then square root 24 has a perfect square that we can break out of that, and we can do that now. So 24 breaks down into 4 times 6, with the square root of 4 being a perfect square, so we finish it with x equals plus or minus 2i square root 6. And there is our answer. You may also run into scenarios where you have both a real part and an imaginary part, also known as a complex number. It's got two parts. So when we're dealing with these, as in these two scenarios, really all you're going to do is combine like terms. You would combine your real parts together, and you would combine your imaginary parts together. So very simply, this first one, we have -6 plus 5i plus 3 minus 2i. So we first combine the real parts, negative 6 plus 3 is negative 3, and then we turn our attention to the imaginary parts, 5i plus negative 2i, which will be plus 3i. Done. The other scenario is there's a minus in there. Make sure that you are aware of that minus, so when you are doing this, we have 3 minus 7, which is negative 4, but don't forget this minus goes to everything. So we also have negative 4i minus 2i, which will be minus 6i. And there is your complex number. Combine like terms. That'll cover it for today. Your assignment, page 279, numbers 3 to 21 all, and 77 to 89 odd. Best of luck to you. We'll see you in class.